Is this live? Okay, I think it's live. Okay. What's up, guys? My name is Michael Lin. Welcome to my YouTube channel. Today, we're going to do this recent Alsing programming contest 2020. I haven't live streamed before, so I'm just guessing this is how a live stream works. But, I don't know. We'll just see what happens, you know? Okay. Let's just do virtual participation. And let's just see. 4 minutes, I'll try to do this contest. So I'm not actually very good at competitive programming. Alright, I'm actually very sucky at this. So if I get stuck on something, I'll just try my best. Okay, guys. Sorry, guys, if I couldn't upload a video for the past 2 weeks. I was busy with work and stuff, so I couldn't actually create any like tutorials and stuff like that. But yeah, this is just my first live stream test. I hope I am live. Am I live? Am I live? I hope I'm live. Am I live? Okay, I don't know. I hope I am live. Okay, otherwise I'm just talking to myself. But yeah, let's just do this contest and then see what happens. The contest will begin in three minutes. This is just a virtual participation. All right, I couldn't actually wake up early to do this contest before, so yeah. But yeah, I don't know. I haven't seen the problems yet. But yeah, we'll just see how it goes. I'm probably gonna do this like every day, probably. I don't know, because I normally upsolve problems from do virtual contests anyway, so might as well try to live stream it, try to see going through my thinking process of how it works. Yeah, I currently I don't really have that much time to do like some tutorials, but yeah, maybe in the future if I have some time I could probably edit some videos and do some tutorials. But yeah, that's just me currently. Just 3 minutes and then I'll start doing the contest. But yeah, let me know what you guys think if you like this live stream type of do stuff. I don't know actually how to communicate with you guys. Let's see. Can I talk with you guys? Oh yeah. Woo! Thanks. Yeah. I am live. Yeah, that's crazy. It's crazy. Yeah, that's amazing. Thanks. Yay! I'll just respond. Yay! I'm live. Yay, I'm live. Okay, that's great. That's awesome. All right, I've never live streamed before. It's amazing. Yeah, the new technology is crazy. It's wild. New technology is wild. But yeah, still gotta wait 2 more minutes before I actually do this virtual contest. I don't know if there's a way to like change it so you don't have to wait 5 minutes before you do a virtual contest. But yeah, I haven't seen any of the problems here yet, so I'm not really so sure. But generally, AtCoder contests are more. I think they're more mathematical, if I have to say so. But that's why it's good for beginners. That's why I think because for me as a beginner, I'm not good at solving problems really fast. If it's like a math problem, right? It takes me time to do it. So in order to reach green, I think on Code Forces you have to solve the problems very, very fast. Like solve the basic math problem, problem A and B very fast, right? If it's brute force or if it's just an implementation or something like that, you gotta solve those problems very fast. Yeah, I'll check the chat later to see what you guys are talking about, but I think there's only 2 people watching. But yeah, the two of you guys, it's awesome. Yeah, it really makes me feel good, right? At least I could have provided some amount of value to you guys. But yeah, let me know if you guys think that programming, like, what do you think of if you like these type of live streams or not? So yeah, because like I don't know, happens. I know like some other YouTube channels live stream also. Like I know some of the Eli the computer guy live streams a lot, so that's what influenced me to start doing this. I also know like Joshua Fluke live streams a lot also. So if you guys watch them, they're pretty cool. Yeah. But yeah, so I'd try and do this. The contest would begin in like 30 seconds, and then I'll just like dive into doing the tasks. Let's see. Let me just pull up. You guys can see my screen, right? Hope you guys can. Not sure. Oh yeah. Okay. So this is what I normally have in before I do any contest. I have like wild T stuff like that. But yeah, this is like all my macros. I use long because it's easier to write LL. There's these 2 lines are just able to just increase like reading in from the console, stuff like that. Yeah, let's see. Oh, okay, now it's starting. Okay, let's do this. Number of multiples. Okay, let's do this. How many multiples of D are these among the integers between L and R inclusive? L and R. D. So read in L, R, D, 5, 10, and 2. Okay, so I'm guessing is that, so multiples, so how many multiples of D, so, okay, so how many multiples of D are there between L and R inclusive? Okay, so we got to print the number of multiples of D among the integers between L and R inclusive. So we have 5, 10, and 2. Okay, so we read in L, D, R, and D. Among the integers between 5 and 10, there are 3 multiples of 2, 2, 6, 8, and 10. Okay, so if I read through, they want the number of multiples, right? So I'm going to guess that you could take the right side minus the left and then divide by D. I'm not sure. Wait, so like 5, if I take 10 minus 5, 5 divided by 2. Can I do that? That might be a ceiling. Let's see. Why don't I try that first? So, okay, so I'm going to create 2 variables, L, R, and then D. 3 variables, my bad. I'll read L, R, and then read a D. And then I'm going to just do like cout R minus L, and then divide by D. And then, yeah, do that. I'm guessing you could do that. That's what I'm guessing. Let's see. We could try it out. 5, 10, and 2. Let's see what that gives us. Whoops. 2. Is that right? No, it's 3. Okay. Maybe it's ceiling. Try ceiling. Cast it as, I could cast it as a double. Ceiling, let's see. Cast as a double, divide, and see if this works. 5, 10, 2. Okay, so that's right. Let's see about this. 2, let's see, is that right? Yeah, that's right. Let's try this. $99. Oh, that's not right. How many print the number of multiples of D among the integers between L and R inclusive? Between L and R, number of multiples. So if I have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so what if okay, let's think about this. If I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is my 10 is my right side, 5 is my left, right? So if I count the number of multiples between 10 of multiples of 2 for up to 10, and then subtract the multiples of 2 up to 5, I should be able to get the ones between 5 and 10. That's what I'm thinking. So that's why I did that. R minus L over 2. But let's see. There might be an issue with including it. Because the multiples of 10, what if I try, okay, so the number of multiples of 2 up to 10 is 5. Number of multiples of 2 up to 5 is 4. So if I do 10, 5 is 4, 2. Oh, let's see. Think. What if I try R over D minus L over D plus 1? What if I try that? Like, I know I have to subtract some multiples. Let's see. R over D. Let's see. Oh, that's 4. Something is. All right, I'm gonna label out on my pen and paper. Try to find the pattern, how to get this. Okay. Let's see. 5, 5, 5, 10, 2, 5, 10, 2. So I have. How many multiples of D are among 5, 6, 7, 8, 9, 10. Another thing, I could loop from L to R, L to R, and then just count the ones that are divisible by D. Actually, that might actually work. Okay, let's try not to do this mathematically then. What if I do that? So like I'd go from L and I go up to R, and I just count the ones that are divisible by D. Then I just do like occurrence, add it if it is divisible. That might actually work, because like the test cases are small. Let's see. Yeah, it's only up to 100, so let's see. There's no like huge boundaries. 3, yeah, that's right. Let's try this one. 2, is that right? Yep, that's 2. Okay, let's try this one. It's 100. Okay, yeah, that's right. Okay, I think this works. Okay. Okay, yeah, it worked. Okay, that's good. That's good. That's good. That's good. Okay, next number. Yeah, so sometimes, guys, if you can't do it mathematically, try to do it. Try to just do it, brute force it. We have n numbers 1 to n. Each square has an integer written on it, and the integer written on square I is a of I. How many I satisfy both of the conditions? Written number I is odd. The written number is odd. Okay, I don't know what that means. Okay, first, might as well just read in the numbers first, though. So, a and create a vector of that. Let's see. Each square has a number, integer written on it. Integer written on square I is a of I. How many squares I satisfy both of the following conditions? Written number I is odd. Written integer is odd. We have 1, 3, 4, 5, 7. 2 squares, 1 and 5. Both satisfy the conditions for square 2 and 4. The satisfied numbers are not odd. For square 3, the written number is not odd. Let me read it again. There are n squares assigned the numbers 1 to n. Each square has an integer written on it, and the integer written on square I is a of I. How many squares satisfy both of the following conditions? Oh, okay, I get it. Okay, I get it. Okay. They just want us to check if the index and the number is odd. So all you have to do is just loop through. So I index it from 1 and then just loop through it. Okay, the written I is odd and the written number is odd. Oh wow, that's actually super. So just check if it's odd. Can you guys see my screen? I don't even know if you can. Let's see. Oh, okay. Okay, that's good that you guys can see my screen. Otherwise, I don't know what I'm doing. Okay. Yep, AC. Okay. All right. So I read on the chat that one of you guys had an issue with C. So let's see if we can do it. Let f of n be the number of triplets of integers x, y, and z that satisfy both of the following conditions: x, y, z, x squared plus y squared plus z squared plus x, y plus y, z plus z, x is equal to n. The number of triplets that satisfy the conditions. So given an integer n, find each of f of 1, f of 2, f of 3, f of 4, up to n. Huh. Okay. I'm going to try to brute force this. Whenever I see something like this, I'm just going to brute force it. Let's see. Okay. Read in n. Alright, so we want to find the number of triples of integers that satisfy both of the following conditions. So we need to find each of 1 up to n. So I'm going to create a function called f. So I'm going to loop from, how are they printing? Okay, wow. So they are actually printing all those. I'm going to loop from 1 to n. So mathematical. Less than or equal to n, I plus plus. I'm going to pass this into function f. Let's see. Yeah, so function f is this. Okay, so then in function f, I'm going to see out f of I. Okay, create a function f. Okay, this is n. Let's try it. Little n. Okay, let's see. Number of triplets x, y, z that satisfy the following conditions: x squared plus y squared plus z squared plus xy plus yz plus zx equal to n. What if I just brute force that? What if I just do x equals 1, x is less than or equal to n, x plus plus. I do 4 y is equal to 1, y is less than or equal to n, y plus plus. And do z. Then if it satisfies this equation, then I add it. So if I do like count, if it satisfies this equation, what is this equation? Let's just copy this. Copy this equation. Whoa. Okay, not what I want to do. Okay, whatever. Pow x squared plus pow y squared plus pow z squared plus x times y plus y times z plus x times is equal to n. So if this is true, I'm going to increase count, and then after that, I'll just return. Return count. Okay. Let's see. Let's see if this works. I'll just try this. Let's try 20. 0 0 0 1 0 0 0 0 0 1 0 0 0 1 2 3 4 5 5 zeros 1 2 3 4 5. Yeah, have a 3. Have a 3, and then we have 1 2 3 4 5 zeros off after that. So have 3 1 2 3 4 5 zeros 3 3 0 0. Okay, I think that works. Try this. If it's TLE, then I'm gonna try to optimize it. Let's see. TLE. Okay. Let's see. We might not actually have to include all the values of n when we loop through it, because it has. We could try to minimize the number of values based on this equation. Right? We don't have to loop through every single value for x, y, and z, because we know it has to equal to n, right? So let's try to see something. What if I factor out this equation? Do like x square plus y square plus z square plus x y plus yz plus yx. Okay, let's see. Another thing, we could try counting it using mathematics, but for now let's try doing this. Let's try optimizing it. Try factoring x squared plus xy plus y squared plus yz plus z squared plus zx. Try factor x plus y plus plus z plus z times z plus x is equal to n. What can I do with this? I don't know where I'm going with this. E c squared x y z y z. No, I can't do that. Let's see. Let's try this. Must be a way. Must be a way to factor. Oh wait, okay. We know it's squared, so x, y, and z are greater than or equal to 1. Okay, so we know that. So we know that it's, if it's squared and if it's greater than or equal to 1, then how do I find the number of values that are add up equal to n? Let's see. How do I do this? Let's see. X squared plus y squared. Let's see. Let me see my virtual standing. Because I didn't solve. Damn. Wow. 6 minutes, 9 minutes, whatever. Whatever. It is what it is. Let's see. There must be a way to solve this. X squared y. X squared plus y squared plus z squared plus xy plus yz plus zx. There must be a way. I'm trying to think. Because if we only have to do it from, like, if I create like a boundary of here, instead of going from 1 to n and 1 to n and 1 to n, and I like based on this equation I could like restrict this final value to be less than n and restrict this one. That might improve the speed a bit. But to another thing is that another thing we could try counting the value, list the numbers that are triplets that work. Let's see. Let me just check the chat real quick. Hey, it's visible. How do you do default Microsoft compiler in VS? There is a theorem. Okay, canal. Okay. There's a theorem. For Okay, x squared plus y squared is equal to 0, then x equals y equals. Well, you don't know though. You don't know if your n is equal to, because n could be anything from 1 to n, Kunal. Right? So you don't. Let's see. You could solve this. How do you use default Microsoft compiler in VS? If you want to use default Microsoft compiler in VS, you could default Microsoft. You just what I did was I just downloaded the Microsoft Visual Studio, and I just I just downloaded Microsoft Visual Studio and I just did it. These libraries, bit/std c++, that this is not included, so you actually have to like download the all the files for stdc++.h. But yeah, or you could just like not do this. You could just do like IO stream, stuff like that. But yeah. Let's see. There's a formula. Is there a formula? Must be a way to restrict this. Let's see. X squared plus y squared plus z squared plus xy plus yz plus zx equal n. It must be your way. Okay, if you do 1. Okay, if n is equal to 1. Squared plus z squared plus z. Find each of 1, 0. X squared plus y squared plus z squared plus xy plus yz plus yz. Let's just assume n is equal to 1. Let's see what are the number of values could be. Only possible ability is 1 and 0. Oh, it's not possible for yz. Because yz is starting from 1, so there would be 0 there. Let's see. So if there's 1, if n is 1, the number of triplets x, y, and z, where x, y, and z is greater than 1, is going to be 0. Because if it's 1, it's going to be 0 because of, there's not an, you can't have 0 as y or z. So if n is 1, number of triplets is 0. Let's see, n is 2. What did they say here? Number triplets still 0. Okay, so n is 2, number triplets is 0. Let's see, n is 3, number triplets is... So what number do they actually have values? 6. They have 6 because of 1, 1, 1. Thus 6 equals to 1. They have 11 because 1, 1, 2, 1, 2, 1, 2, 1, 1 satisfy the condition. Thus f of 6 is equal to 3. Oh, what if I work backwards? What if I only plug in the values of x from x, y, and z, plugging in numbers from like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to n, and then, so originally we're counting these and checking if it equals to n, right? And then plus plus. What if I were to pre-compute the number of values first from 1 and z up to 10 to the 4th, because n is only 10 to the 4th. And then if I were to pre-compute those, put it into like some sort of hash set maybe, or not hash set, not hash set, map, put in a map maybe I could do this. Let's see, 1, 1, 1 gets you n is equal to 6, so that's why 1, 1, 1, 2, and it's 17, 1, 2, 2, 2, 1, 1, 2, 1, 2, 17, trying to think. I'm trying to think. So for each number, there's 3 different types of triplets because each number could go through 1, 2, 3. So what if we were to try the numbers of like 112 and then 113, 114, right? All those values, find their corresponding n from here, and then based on that, print out zeros for the rest. I'm gonna do it up to n. So like okay, let me see. Okay, what if I do, instead of doing this, so like, hold up, I'm gonna do like I'm gonna comment this out for a second. What if I do for I equal 1, I is less than equal to n, I plus plus, and I just calculate all the values for x, y, and z. Whoops. Let's just see what each n value is. So like, print out this. Because that's the number of n, like, this value is the equation has n. Then if I pre-compute these values, I don't have to, I'm trying to think. Because if I pre-compute these values, all the numbers from 1 to n, then I can make the rest zeros, right? That don't satisfy the specific index of n. Like if I do like let's say I brute force all these, right? And I get this specific value of n. Then I put that in like a hash map. Then if this doesn't work, then I'm gonna loop through from 1 to n again. And if those aren't in the hash map, maybe I could just print out zeros. You know what I mean? Yeah, I'm gonna try that. So I'm gonna do this. Let's call this value. This is the equation. Let's just print out the values and see what they are first. Okay, let's say I do 20. All right, let's wait. I'm just waiting for a second. Okay, yeah, so it goes up to 2,400. The number of values. Okay, so it stops at here, 6, 11, and 18. When it's greater than 20, we could stop, right? So if my value is greater than 20, I'm going to break because those are the only n values that are possible. And then I need to keep track of I need to find, so I got these 6, 11, 17, 18. Oh, there's no 17. Why is there no 17? That's weird. Why is there no 17? You have 1, 2, 2, 2, 1, 1, 2, 2, 1. I should have 1, 2, 2. Should be 17. That's weird. There's no 17. 1, 2, 2, 1, 2, 2. There's no 17. It's weird that there's no 17. That's just weird. Okay, I kind of think that's kind of weird. Must be a way to change the boundaries. Something like that. Let's see. What does the chat say? Here's a theorem. Okay. Must be a way to change the boundaries. N. What if I go from n minus... Oh, what if I do this? N minus y, and I do n minus x. Try that. Let's see, hold up. Fudge. Just wait. Oh, whoops. Why is it not working? So 6, 11, 18, 27. Okay, so if, let's do this. If value is greater than n, reset pause is false. Let me do this. This is a hacky way of doing it, so I could use breaks. So that I could break out of this loop. Break out all these loops. That's this hacky way of doing it. Six, 11, 18. But the problem is, why isn't 17 working? Let's see. Because I want the ones that are up to n, and then the ones I don't, I could try to find a way. Because if I find all the n's that are, find all the x, y, and z that go up to n, the rest I could put all as zeros, right? So like this. So 6, 17, 18, I could say that all these are 3, and the rest are zeros, right? Except for 1, 1, 1. All right, so if x, y, and z is 1, 1, 1, then I said like that's 1. Okay, 3, 3, 3. Or if it's like the same, like 3, 3, 3, then I say it's like 1. Now I have to find why this is not working. So I have 2. Okay, let's do y. Oh, wait a minute. Why should we go to? Why should go up to 20? Maybe not this. Maybe we shouldn't break like this. Must be a way. 6, 18, 11, 17, 18, 11, 17, 17, 18. Yes, okay, so that works. Okay. All right, that works. So now I have the ends. Now what I need to do is that I need to check the ones that are not keep a number of occurrences, I think. Cuz like let's see. There's 6, 11, 18, 11, 17, 18. So there's 1, 2, 3. There's 3 17s, 3 11s, 1 6. So yeah, I just need a map to keep that track of that. So I'll do that. So I'll just do like occurrence. Yeah, and then I'll just do here I'm gonna do map occur at value plus plus. Right, so then okay, so what I'm doing is I'm getting all the values that are x, y, and z. The n's are less than that, and then I'm just the equation. Okay, so basically what I'm doing, I'm getting all the values that satisfy this equation of n, and then once I have those values like 6, 11, 17, 18, I keep track of number of occurrences. So then that's the number of occurrences, right? So then I could just print out 1, 3, 3, 3, and then the rest I could put at 0, right? That's what I'm doing. So then I could just do in occur. Okay, so no, I need to do for I is 1, I is less than equal to I plus plus. Okay, and then now I need to do like occur at I if it's not equal to 0. I could just print occur at I. I could do that. Let's see. 0 0 0 0 0 1 0 0 0 0 3 0 0 0 3. Okay, 3 3 0 0 3 3 0 0 6 1 2 3 4 5 1 2 3 1 2 3 4 5 3 3 0. Okay, yeah. Okay, I think this works. Okay, let's see. No TLE, no TLE, no TLE, no TLE. Give me wrong answer at least. Yes, I got AC. Okay, that's what I got. All right, what are you guys doing? Okay. Actually, I didn't do that. But yeah, that's my fault. I didn't do up to square root n. I did like y minus x. But yeah, let's go to the next question. All right, anything goes to 0. Oh my god. Okay, I haven't gone this far yet. All right, let pop count be n, be the number of ones in the binary representation of n. Pop count 3 is equal to 2. Pop count of 7 equals to 3. Pop count of 0 equals 0. Let f of n be the number of times the following operation will be done when we repeat it until n becomes 0. Replace n with the remainder when n is divided by f. Oh my gosh. Okay. Ooh. Okay. We need to use this is bitwise. Bit masking. Let f of n be the number of times the follow operation when done, we repeat it until n becomes 0. Okay. Wow. Okay. So the constraints are harder on this one. It's to 2 to the 5th, 2 times 10 to the 5th. So yeah, well, that's hard. Okay. Okay. So C and N, C and X. Okay, I'll do that. Can you guys see my screen? But okay, never mind. Okay. Okay. Yeah. Okay. Yeah, you guys could see my screen. Okay. Yes, Kunal. I feel the same happiness as seeing AC. AC is awesome. Seeing AC is awesome. Seeing AC is very awesome. Okay. Let's see. Pop count and okay. C and N, C and X. Okay, I gotta do that. Number of ones in the binary representation of n. So pop count 3 is 2, pop count 7 is 3, pop count 0 is 0. Okay, so maybe I could do some bit masking to get the number of ones in the binary representation of n. Okay, I could do that. So I could create like a function of pop count. Let f of n be the number of times the following operation will be done when we repeat it until n becomes 0. So we could replace n with the remainder when n is divided by pop count. Okay, I'm gonna brute force it. Hopefully it works. If it doesn't work, then I need to do what could I do? I have to find like a pattern using bit masks, but for now let's just try brute forcing it. Okay, so we could create a function called pop count that counts the number of ones in the binary representation of n. That's what we could do. And then what we could do is we could repeat this. Do program the exact same thing of this is doing. Okay, so let's do that. Okay, so we could do, so I don't need this anymore. So I could create pop count. Okay, so what it does is I need to find the number of ones in the binary representation. So I could do Okay, so ones. You shift right and then multiply and by 1 to do that, and check if it's equal to 1, and then add that. Maybe I could do that. Let me see if I could do it. So I could do n while n is greater than 0. I'm going to shift right by 1. Wait. Okay, hold up. How to count a number of ones in binary representation. It might be a way to do it bitwise. Okay, I was gonna do this way, but not so sure if I really want to do that. Simple loop. There might be a faster way. Count set. And equals. This works. I don't even know that. Brian Kula's algorithm? That's a thing? Lookup table. O of 1 lookup table. Map each with a bit. What is this? O of 1. Maybe we could use a lookup table. I could do that. Let's try that. Let's use a lookup table. I don't know what this code is doing though. Why don't, yeah, let's just do the recursive approach. Let's see. Recursive approach is log of n. Let's just try recursive approach, because like we're gonna brute force this anyway. So if the recursive doesn't work, then we'll just do okay, so if n is equal to 0, then otherwise we would return this and by n minus 1. Okay. So yeah, okay, that's pop count. Let's see. Now let f of n be the number of times the following operation will be done. When we repeat it until n becomes 0, replace n with the remainder when n is divided by pop count. Okay, so we just do x of 2 up to xn. Let x of I be what x becomes when the ith bit from the top is inverted. What? What does that even mean? The ith bit from the top is inverted. Any of you guys ever solved the D problem? User versus monster. What year are you in school? I'm on my final year of college. That's what I'm doing. Yeah. USA man versus mass veto. I don't know what that is. USA man versus mass. What is that? What is that? Oh, UFC. Oh. This is a US. Are you talking about UFC fighting? Is that what you're talking about? Azure? Is that how you pronounce your name? Whatever. It is what it is. Okay, we have to divide by pop count n. Let f of n be the number of times the following operation is doing. You repeat it until n becomes 0. You take it, n equals the remainder divided by n. Okay, so I'm going to do that. So n is, I'm going to code f of n. So we're going to call pop count. Number of times the following operation is done. Okay, so this is like times while n is greater than 0. We're going to call pop count. So we're going to do n is equal to pop count of n. You said divide by it. So replace n with the remainder when n is divided by pop count of n. So I'll do n mod pop count. Remainder n is, so yeah, n equal n mod count. And then times plus plus. Okay. And then after that, I'll just return times. Okay. So that's the number of times. Calling pop count when you, I just coded up this f of n. That's what I did. It can be proven that under the constraints of the problem, n always becomes 0 after a finite number of operations. Yeah, okay, so okay. Now you're given x with n digits in binary for each integer I such that I is less greater than n. Let x of I be what x becomes when ith bit from the top is inverted. I don't know what that means. So, let's see, 011. 011. So if the, what? 2021, 2 plus 0, x of 1. Seven one zero. This the ith bit is inverted. Ith bit is inverted. So if we, okay, so what if we invert we find the value, we invert the ith bit, then we pass it into the function, and then we print it out. All right, we're brute forcing it. Okay, we're gonna invert the ith bit, pass it in the function. Yeah, I hope this works. Okay, so how do you invert the ith bit? Loop from 1 to n. How do I loop the ith bit? Oh my god, how do I loop the ith bit? So invert the ith bit. Invert the ith bit, then we gotta pass that into the f function and then print that out. So invert, let's do invert, let's invert ith bit, and then pass it into this function f. So cout f of okay. How do I invert the ith bit? Toggling the ith bit of a number. Shift the number by k minus 1 to create a number that has only ith bit as set. Return the XOR of the number. Oh, okay. Shift it by k minus 1. So for it, return it. So this, oh, okay. So they shift it. So if I want to change the ith bit of 1, I gotta flip it, XOR it, toggle ith bit. Okay, I'll do this. That's just a little copy and pasty, you know what I mean? Toggle ith bit. XOR it with 1 shifted left by k minus 1. Huh, okay. Toggle, so I'm gonna do toggle value is equal to toggle kth bit. Pass in n. Whoa, what just happened? Am I still streaming? Oh, whoa. Hope I am. College, I'm in the final year of college. Yeah, I'm not that fast at coding, so. Acer. Huh. N I I think this would work, assuming that fudge cakes. It should work. Let's see. 112, 112. Ah, it's 211. Let's see. Toggle ith bit. Maybe I have to. Maybe I have to do just K. One, two, two. No, that's not right. Toggle ith bit. Toggle the. Oh, I minus one. What am I doing? Hold up. 011. No, that's not right. Toggle the ith bit. I toggled it. A paladin value. Why is it 211? Maybe it's backwards, so maybe I have to like print it out the other way. Maybe that's why. 2 1 2 2 1 2 1 2 2 1 2 2 2 1 2 1 2 2. There's a 3. There's all 3. I don't have a 3. When is equal to 0? That's f of 1 is equal to 1. How much time do I have left? Let's see. I know some people could solve these so fast. It's kind of crazy. Spades. Ace of spades. Okay, yeah, so... Wow, I have a lot of work to do. 30th place. Maybe I could have increased my ranking at this point. I don't know. I have no idea. I shouldn't have done this as a virtual. I should have woken up early and do this. Invert the ith bit. I did that. Overflow. Let's see what the value of. Should give me 7. Whoops. What? Hold up. How do I get it? Okay, yeah. Let's see. Should give me 7. Okay, you know what? I'm gonna try this. For now, let's just comment these out. X of 1 should give me 7. What's the problem? Oh. Gives me 2. Oh, these aren't actually the... Oh my god, okay. This is not... It reads it as... X is not in binary. X is a number. I have to change X into binary. No, I need to change X into a number. And then I could toggle the ith bit. Otherwise, I can't do that. Okay, so... okay. Let's see. I gotta think. 2, 3. Okay, so I have to... Okay. So when I toggle the ith bit, I can't actually do this. I can't use this function. I have to actually loop through it. And then another thing, I can make it x into a bit set. So like convert x into a bit set. Convert x and convert a number to bit set. I try that. But then you have to read it by string. Wait, hold up. Let me see something. Or I could just loop through and change it, the ith bit. Okay. All right. I'll create my own change bit. Let's see, change bit. Okay. Let's do this. We could create a bit set of n values, and then we have, that'll be our g or whatever, something like that. And then I need to read in the bit set. So read in the bit set for x. So yeah, I'm gonna do this, and I'm gonna do for I equals 0, I is less than n, I plus plus. I'm gonna read in the bit set. Okay, now I just have to loop through it and then invert the ith bit and then print it out. Yeah, this is still brute forcing, so there's probably won't at all. This probably won't work at all. I should make this a global variable actually. Make this a global variable. So let's do this, and then how many? What's the maximum? 2 to the 5th, so 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait, no, 2. Wait, hold up. 1, 2, 3, 4, 5. Yeah. Okay. Okay. I'm gonna create a breakpoint here. Toggle ith bit. Change bit. I'll do this later. What's the problem? Oh, whoops. Oof. I don't need this. Why is this not working? You can't read in the bit set. Huh. You actually can't read in a bit set. Can I convert a number to a bit set? Oh man, this is so difficult. Bit sets are hard. Can I convert a number into a bit set? Let's see. I don't think I could convert this into its equivalent number. So like 1 times 2 to the 0 plus 1 times 2 to the 1. So 2 plus 0. 2 plus 1, which is 3. 3 plus 0. Okay, so 3, invert 3. That gets you that. I'm gonna convert this to a number. Screw it. Okay, we're not using bit sets. We're gonna convert it into a number. So now then I could use this toggle again. Okay, so Yeah, I could do this. Could do this. Make this L, make this L. Okay. Okay, so I could get this out of the way and then I return wait. Return decimal number. Okay. Okay. Alright, so I'm gonna read an X, change it into the actual decimal number. I'm gonna change decimal. So now this is the actual value. Now let's see what happens if I toggle the ith bit. Now, let's see, values, let's toggle X ith bit of 1. Let's see what that gives us. So if I do like, gives us 10. That's not what I want. I want to get 7. If I toggle the ith bit. What is our val though? That's a big question. Oh. Whoops. Let's see. Value is 2. That's not right. Hold up. Val's 3. Yeah, that's right. Val is 3. Toggle the ith bit. The I minus. Maybe it's 0 bit. No, that's not right. That's not right. Ah. Oh boy, this is gonna be so hard. This is hard. It's a hard problem. I haven't done bit math in ages. Oh my god. How much time do we have left? 36 minutes left. Oh boy. Oh boy. 36 minutes left. Oh my gosh. This is really, really tough. This is tough. I know William Lin is the best. He's really good. He's like really young though. That's the thing. William Lin started a while back though, so yeah. Oh, gee. Yeah, it's not that serious. Not that serious. I'm sort of serious though. Very serious. I was trying to figure this out. Any of you guys figured out how to do number D? Letter D? Anything goes to 0. Popcorn N. Number of N. Let's see. What can we do? How do we do this? Okay, first let's try to go back to brute forcing. Okay, so this value is 0, 1, 0, 1, 2, 3, 0, 1. Let's see. 2, 1 times 2 is 0. 1 times 2 to 2. I flip the ith bit of 1. From the top. Oh, the ith bit from the top. So, wait. If so, 0, 1, 1. Okay, so 0, 1, 1 becomes 3. If I flip the ith bit from the top, this that means I flip this 0. So that would be 1, 1, 1. So I think that's how they get 7. Let's see, 0, 1, 2, 1, 2, 2. So let's get 4 plus 2 plus 1. Yeah, okay. Oh, okay. I think I get it. Okay, so from the top it would be, this should give you 7. Let's see. No, that didn't give me 7. Why didn't it give me 7? Flip the ith bit. Value should be 7. Hold up. N is 0, 1, 2. N is 3. So flip the second bit. Should give me 7 from the top. I don't understand. Why is this not working? Let's see. It's 2. Shift left by 3. XOR. Should be. Maybe give me 1. Let's see. One, 0, 1, 1. It's okay. No, barely anyone's watching. You don't have to retract your message, Asser. I don't really care that much. Live streaming is so cool, though. By the way, what time zone are you guys in right now? I know most of my viewers are like from in India, so. Is it like at nighttime right now for you guys, or in the morning? Let's see. How are we gonna do this? How are we gonna do this? NX. Still trying to think. How are we gonna do this? Oh crap, it's 3 a.m. right now. Yeah, maybe I shouldn't have live streamed at that time. What's the best time what's the best time for you guys to live stream? Then 3 a.m. Wow. Sorry guys, in the US right now it's like 7 p.m. So well, no wonder no one's here right now. I'll just see like it is what it is. Pop count. This is a really tough question. It's not just like, I can't even get the brute force to work right now. Whoops. Toggle ith bit. Oh, this is toggle. Wait. Does this... What's the best time for you to live stream? for you guys at least? Like middle time, daytime? Oh, whatever. It is what it is. What it is. How are we gonna get this to work? How are we gonna get this to work? This is tough. This is very tough. Very, very tough. Very tough. Pop, divide by, count, divide by, let's see. Yeah, my standing is not good right now. Virtual standing, I'm doing pretty well right now. Well, there's not many people in virtual standing now. Huh. I feel like a few people are stuck on D. D is hard. Orange Coder had an issue with D. What's brown? What are the rankings for this, by the way? Oh, so it's gray and then brown and then orange or red. Not red. Gray, brown, and then green. Yeah. Huh. That's cool. Didn't even know that. 81 playbacks. I don't know. It's okay, guys. You don't have to be watching right now. I've never live streamed before at all. So that's why. This is really cool though. Not gonna lie, it's really cool. This is tough. This is tough. 7 p.m. in India. Okay, so if the problem is that 7 p.m. in India, it would be like here. Okay, that would be this time that the actual contest is at. That's a issue. So like, unless I do it like, let's see, oh, I could do. Oh wait, I could do that. Maybe I could do that. I don't know. It's like 10 a.m. in my time zone. So yeah, maybe I could do that. Sorry guys if no one's watching at 4 a.m. All right, maybe tomorrow I'll live stream at 10 for me in the morning. So then it'll be 7 p.m. in India time. So yeah. I don't know, like, wait, let me see. What is, okay, The best time to live stream is during lunch, right? Oh, so that means I have to wake up at 3:30 in US if I want to live stream. Okay. Yeah. That's what I'm talking about doing. Yeah, getting AC is really nice. Trying to solving it. Yeah. Yeah. I don't want to keep you guys late though. Keep you guys up late. Nah. So, it is what it is though. What it is. This is very, very tough. Maybe I'll live stream at 3:30 a.m. in the morning in US time, so then it'll be 1 p.m. in India. So then that'll be the best time to live stream. But for now-ish, this is still pretty difficult. Problem statement. Still problem statement. Oh. Okay. Wow. Dude, I wonder how other people, how they live stream though, because like they don't have that much. Should I keep this live stream up on my channel? What do you guys think? What do you guys think, guys? Oh my god, popcorn. This is so difficult. This problem D is so difficult. My god. Might be a way. Might be a way. Toggle the ith bit. So I'm toggling the ith bit from n-1. So 0, 1, 2, 3 toggle ith bit should be. This should still give me. Why isn't this working? K minus 1. What if I do this? Actually, let's see something. N minus 2. How do I toggle the ith bit for 7? I need to get 7. Value's 2. How did he do that? Value's 1. Huh. What if I toggle the nth bit? N bit. Third bit. Let's see. Will I get 7? Oh! Okay, I got 7. Oh, that's good. Okay, okay, I got it. I got it. Okay. Okay. We'll do this. Okay. F value of value. Okay. Yeah, so I got the ith bit right. Now this should work now. But keep in mind, this is still brute force, so Whoops. So first one should be 2. Yeah. Yeah. So I get 2. Wait a minute. 2, 7, 2, 1, 0. Wait. Hold up. Oh, I'm seeing out this wrong. Okay. Yeah. Okay. Let's delete this. Take out these break statements. 2, 2, 2. Ah, that's wrong. Why is that wrong? 2, 2, 2. Bit F value. Still gotta keep struggling. Struggle's real. The struggle's so difficult. Should I keep these live streams on the channel though? In case you guys want to watch it again? I don't know what this means. Maybe. I don't know. See, Ricto, I don't know. He's like... Because if I have a channel just for live streaming, then... I feel like Ricto... I feel like he could have just merged his 2 channels into one. I don't really see like a point having like 2 live streams. Like a channel just for live streaming. You know what I mean? Like the point of live streaming is to try to get people to chat with your subscribers, right? So like if he... I don't know. I'm not sure. Okay. Alright guys, I'm gonna have to end this live stream. Rate, comment, subscribe. I'll check the editorial. I couldn't get the problem D right. But yeah. Check you guys later. Peace.